I have a project where I want a server rack in a fairly limited space, but I don't want to pay $150 for one. So can I 3D print one instead? Jeff Geerling's channel put me onto these miniature 10-inch server racks, and at the time, I really didn't see the point of them until I had the perfect use case. I've been working on my partner Ruby's space Thorne tattoo, a new shop in Portland, Oregon, and it's pretty small, with just 50 square feet of it being dedicated to an office. I need to get a good Wi-Fi setup in there for clients and for business needs, as well as a good surveillance system to secure the property. So good hardware going into a little rack like this makes sense, but at $150, I paid the same amount for my 42U Dell server rack that I got off of Facebook Marketplace back in Philadelphia. But of course, in a tiny 50 square foot office, I'm not shoving a full server rack in the corner. So in comes the fact that I have 3D design skills, I have a small army of 3D printers, and a spool of filament like this, that's $30. And that's good quality filament. So can I 3D print a miniature server rack for my networking needs at Thorne Tattoo? Let's find out. All right. Real talk. You probably clicked on a thumbnail that showed you a completed rack, so clearly it can be done. But as of right now, while I'm filming this video, I've designed it, I've printed it, but I actually haven't assembled it yet. So I don't even know if it's gonna work out the way I'm hoping it will. So there's plenty of questions left to be answered. Does it work the way I want it to? Is it worth doing? I mean, how much filament does it take to make one of these things? How long does it take to print? Where can you get the design files to make one for yourself? And of course, we've got to deploy it at Thorne Tattoo with the new networking hardware for that space and see how it works in operation. First and foremost, I think we should probably take a look at the completed design. Without further ado, I present to you what I have dubbed Mod10, a modular 10-inch 3D printable server rack. At a bare minimum, you only need 3 3D print files and one fairly standard set of hardware to put this all together. There's a top and bottom piece, which is the same piece just flipped over depending whether it's the top or the bottom, a cross member that ties the two sides together, and then there are these connector pieces that are used with the hardware to tie it all together. Speaking of which, the only hardware the entire unit uses to be held together, whether you're bolting the different sections together, mounting hardware in it, putting handles on it, feet on it, is regular cage nuts and screws for server racks. I'm using these M6 ones that I will have linked in the description. They're the only ones I've tested in this application and what I designed around. I can't confirm that all cage nuts are gonna fit, but they are a fairly standard size, so they should. Now, if 4U isn't enough for you, you can go up to 6U or 8U by just adding a mid-section piece. Again, this is just one more 3D print file, so a total of 4 3D print files to put together the full outer frame of an 8U or a 6U unit. And of course, I've created a base ecosystem of blanking panels, keystone plates, vented blanking panels, top lids, handles, and even a 40mm fan mount to go in this as well. And I'll tell you right now, modularity in this design was actually kind of an accident. I landed on it because I wanted to make sure that the printed parts would fit onto smaller build volumes. I have 500mm machines, but I didn't want you to have that if you wanted to print one of these things. So I designed it to fit on the bed of a Prusa Mark IV, a Core 1, or Bamboo X1. So all of the 3D print files that are available should fit within the build volume of one of those machines. And all of this is designed around the current 10-inch server rack standard in 1U increments. So pieces from that DeskPi Rackmate or other 1U hardware out there should fit. In fact, I've already grabbed some printable models off of Printables for the hardware we're going to be putting in rather than design my own. I'm certain there's more to discuss, and I'll need to make sure all of this really works as well as I hope it does. I've iterated and tested, making sure the cage nuts fit how I want and the strength of the components is where I want it, but I haven't fully built it yet. So let's do that. Insertion of the cage nuts is as annoying as it can be on any server rack build. It was just the thing that made the most sense to me to have one set of hardware for all of this. When inserting these things, a flathead screwdriver can really help you to shoehorn them into place on any of them, but especially so on the very top and bottom flanges. These are slightly thicker than the rest to reinforce them for the handles or the foot mounting. As this is all going together, yeah, cage nuts can be a little bit annoying, but once you get the hang of them, they really start to roll and get into there pretty simply. What I do see is this is not necessarily the most hardware efficient design, but I don't really see how I could cut corners too much. I filled out enough pieces to put together a 6U rack. I printed enough pieces for 8U, but I don't know if I'm going to have enough cage nuts for that, because at 6U, I'm using a minimum of 60 cage nuts to put this together. I realize that's a lot of cage nuts to put this all together, but I didn't want to have a mix and match of hardware and try to make people buy 3 different sets of things just to make this all go together. You can buy just cage nuts and put this together. That was my goal. This crossmember is what ties each half of this rack together. It's the top and bottom crossmember. There are 4 of them in total to put one of these together. It uses 2 M6 screws at each side of it to hold it in place. And the very top 2 holes and cage nuts are purely for this crossmember. They're not for any rack unit 1U or any of that type of spacing. They are just for this crossmember. The side panels have this key step in the middle of them. That is an alignment joint. It doesn't really mechanically hold things together, but it does help line things up while you're assembling. Tolerances need a little work here. I'll get that tuned in. If you want to assemble a 4U unit, you use 2 of the top bottom pieces just flipped over on top of each other, and then they're connected mechanically with cage nuts and M6 screws and these connector pieces that tie the top and bottom together. If you're looking to do 6U or greater, you use one of these mid pieces that goes in between the top and bottom section. It is 2U for each one of these to extend up. There's a solid top panel and a vented top panel. I'm using one of each on my build. This is the vented panel, which mounts to the inner 2 holes on the top or bottom of the piece. And then of course your blanking plates, your shelves, your keystone jack plates, they all mount like any other 1U, 2U, multi-U server components would for a rack. One more important piece of assembly components is this little strap. It's just a small piece with 2 holes in it. The idea is it bridges across one rack unit to the next rack unit where modular sections come together to hold the front section together just a little bit better. It's just an additional tie piece. And that's largely the assembly. I wanted to show what a 4U would look like. This is the assembly right here with just 4 rack units. For my purposes, I added the mid sections in. That'll get me up to 6U. That's how much hardware I have available to me, but I think it's actually going to be just right for the setup that I'm putting together. I mocked it up with blanking plates for now. We'll get to the actual hardware that's going into this thing once we get over to Black Thorne Tattoo. And that, folks, was legitimately the first time that I have assembled the Mod10 in its entirety. I am thrilled with the way this is turning out. I could see making some minor tolerance changes to this, but for the most part, I think it's ready for prime time. As such, I'm going to grab it by the one handle. I definitely didn't forget to print the other one. I do have a purpose for not having a handle on this side right now. Let's go grab the hardware that's going to go into this thing and get it deployed. I do have a bit of a problem in here right now, though. A distinct lack of a work surface. You see, I took everything that was in this space and I lumped it all up in the middle of the room, covered it up with plastic. I am going to pull one thing out from under this plastic, something from this video's sponsor, FlexiSpot. I know folks will question whether or not YouTubers actually use the products that they feature, and I can tell you for a fact, when it comes to FlexiSpot, I 1000% do. I use these to their fullest because so much of our lives are spent at desks these days. Whether I'm sitting down to do a video edit or a CAD design, I can stand up when I need to take a break and get some better posture but keep getting work done. I can use it as a workbench and lower it down even lower to get over top of the project that I'm working on. I adore my FlexiSpot desks. Assembly of this thing is thoroughly straightforward. The folks at FlexiSpot sent over the E7W Pro for Ruby to have here. It's excellent for her because she really likes to change up her work environment on a regular basis. So she can go from the seated position, lower it down a little further for drawing at her tablet, raise it up even higher for standing at the desk to take a break from sitting all day long. It is such a versatile situation with just one desk. That beefy construction means these things are strong. I and my kids sitting on this thing are nowhere near the 440-pound weight rating that this thing can lift. So if you're in the market for a high-quality electric standing desk, I highly recommend you check out the link in the description to FlexiSpot. You can use this discount code at checkout to save $50 off your order, and thanks again to FlexiSpot for sponsoring this video. Now let's get to assembling our mini server rack. Before we take a look at the hardware we're actually going to be using in this thing, I'm going to take the blanking plates that I put in this just to demonstrate it to you folks out of here and get us a blank slate to start from. Then I get to grab this big box for our little rack. This is hefty. That box is of course not all the hardware that's going into the rack. These are the key components that are going to be in that unit. Content creator note here, I applaud Ubiquiti on one, producing excellent hardware, of course, but two, the packaging. It's minimal, so it's not wasteful, it's easily recycled, but it's also really underwhelming to look at when you're trying to film it for a video like this. With the hardware out of the boxes, it's a little clearer what we're working with here. So let's just do a quick rundown of what hardware we're going to be running in this setup. Let's start from what's going to be in the top of the rack and work our way. I gave Nori a squeaky toy. That was a mistake. Can I help you? Let's do a quick rundown of what hardware Ubiquiti provided for the studio setup, starting from the top and working our way down. Our access point, what we're going to have in here is Wi-Fi 7 from their new Express 7. This is actually a gateway, so it can handle WAN functionality coming from your router into this, controlling Unify OS, and be a Wi-Fi 7 access point, but we're only going to be using it as an access point. This thing has a USB-C input for power delivery to it. It has a 10 gigabit WAN port for connection to your multi-gigabit fiber connection you might have in your space, we don't here, and a 2.5 gigabit out port to go to a router. But again, we're using it as an AP. For anybody who's not familiar, that basically means that that's going to be our Wi-Fi antenna, sort of providing the Wi-Fi in the space. Now, what's actually going to run the show for us is this, the Cloud Gateway Max. This is a fairly new product from Ubiquiti, and this is our gateway. So our internet connection is going to come into this, and it's going to be our Unify OS control system. So it's going to allow us to have all the functionality of Unify OS. This will be the brains of the operation. And it's also going to be our NVR, so network video recorder for security cameras we're going to be putting up in here with Unify Protect. Unify sent over a 1 terabyte SSD that's going inside of this thing, and that's going to give us a terabyte of local storage, and we're going to work on a remote backup setup so we always have footage saved offsite. All the ports on this are 2.5 gigabit, so this will be great to go to that Wi-Fi 7 access point to have good high-speed network connectivity within this space. And last, but potentially least, is the Ultra 60 watt. This is a PoE 8-port 1 gigabit switch. The only reason we really need this is for our security cameras. They are going to be PoE, power over Ethernet. So this is our switch to connect them to our network, but also to provide power to them. So right up there on the ceiling behind me is a junction box that I put in with a couple of conduits, one running into the office and one running through that wall. Because just on the other side of that wall is actually a Wi-Fi router setup for the internet in this building. But it's open to everybody in this building and we don't have control over it. So I'm going to wire to it so we have our own dedicated and secured network connection for what we want to do. Of course, to get it wired up, I have to pull my own cable from that utility room through this conduit into the office space. Doing it this way does mean I need to terminate my own cable ends, which means I have to have the tools to do so, but I do this on a fairly regular basis now. I just find it superior, it's a little bit cheaper in the long run, and you get the cable lengths you actually need for your application, not extra long or too short. A quick test to ensure my crimps are right and we can get hooked up and start configuring our network. I'm bench configuring things ahead of time so I don't have to troubleshoot things in the server rack later. I can just get it all set up here and ready to roll. And with that, we've got our network spaghetti monstered on my desk here, but at least it's pre-set up and ready to roll. I have Wi-Fi 7 set up for the network when it comes to anybody who works here having access to it. We're probably gonna end up putting a NAS in here. There'll probably be a dedicated computer in this office space. So that will all be on one network. And then there's a guest network, so clients can still access the internet, but not have access to our network for the office space. With all that configuration done, it's time to break all this down and get it into the Mod10 rack. Let's start from the top and work our way down. The thing that's gonna go in the top of this is the Express 7, which, as I mentioned earlier, is our Wi-Fi access point. So I want it at the top, since the only thing above it's gonna be plastic, no metal, no other electronics. So it's got a more open, clear signal for the antenna to get good Wi-Fi within this space. This is also the thing you're probably gonna be least impressed by how I'm gonna mount it. I just printed a random shelf that I got off of printables. All the mounts that I'm gonna be using to put this hardware in here are not my design. I downloaded them off of printables, and I'll have links to the files I used in the description. As I mentioned earlier, the Express 7 is almost brand new, so I didn't find any mounts for this yet that others had released. So I'm just gonna use this shelf, sit it on the shelf, and put it up in the top here. Now, something I was actually able to find a dedicated mount for is the Gateway Max. This does have a mount that I was able to download off printables. It slips in from the back side of this, and then once slid in, a pair of M3 screws go down through to retain it into the mount. Honestly, this is a pretty darn well designed piece. My print quality on it's pretty garbage because I printed it on an entirely untuned 0.8mm profile. But the design with the retaining screws, they just miss the actual body of this, but hold it in nicely. You still got the screen on the front of it. It's kind of flush right to the face of this. It even has a couple of keystone jack points on the front of it, though I'm not going to be using those. And then the Gateway Max will go right underneath the Express 7. Again, for the Ultra 60 watt, I was able to find a mount on printables, and this just kind of shoehorns into this. That's a really secure hold on that, and I appreciate the design being that well fit to this. And of course, this can go right underneath our Gateway Max. The connection for it was on the back side, so that'll be hidden within the unit itself. As I'm putting this in, this does fall between two of the sections of my design, so I have to use one of the little connector pieces to tie those sections together and give it a little more overall strength to the structure. Then, of course, our keystone jack plate just goes in underneath of our PoE switch. And I picked up a set of these patch cables to tie the switch to the keystone jack plate. Simply and really clean. With those connections made, we could put a 2U blanking plate on to close out the bottom. I probably could have gotten away with a 4U version of this, but I tried to fit a UPS in the bottom of it to power the whole thing, which didn't go well, as you can see. I'm gonna save you listening to me curse about this and just move on. So while I'm disappointed that we're not getting the PDU in there, I'm not upset about the 6U providing me plenty of space for the spaghetti cable mess that I've got inside of there. I had a couple of longer patch cables going from the front keystone jack plate to this back one, which I can now jump off of for all my external connections here, so it looks clean on the front, and any of my actual connections I need to make can go to this back panel. And I can just close off the rest of this with a couple of blanking plates until I get the PDU that I need to actually power this thing up. This isn't the end of the project, but this is our completed Mod 10 rack. I'm actually thrilled with the way this turned out. Overall, yeah, I've seen a few things I need to tweak. The keystone jacks fit in a little tighter than I wanted them to, so one or two tweaks on my files. By the time you folks get your hands on them, they will be tuned in, I believe. And it's gonna let me have a solid network connection here that I can just keep in this compact, clean little rack to not have a mess of cables around this office. On that note, it's getting late anyway. Let's head back to the studio and do our wrap up, our final thoughts on this project. Let's go ahead and get the elephant in the room out of the way first. The thing that I know plenty of people are going to be asking. How much material does it take to produce that? How long does that take to print? To give you those numbers, I want to get some quick things out of the way here. Print parameters being first. I designed these parts to be 100% support free, but you have to follow my parameters strictly. I can't guarantee print quality or that it's going to work out the way I intend for fits on any other nozzle size, wall thicknesses, anything. I recommend a 0.4mm nozzle at a 0.2mm layer height with 4 walls, aka perimeters, 6 top and bottom layers, and 40% infill of your choice. Also, all the numbers I'm providing you and the material that I actually chose to use are ASA. I say that because something people don't often realize is ASA is actually a lighter material. It has a lower density than others. So if you went from PLA to ASA on your project, you automatically made the project lighter. I also think it's a great material choice for a project like this. It's pretty strong and it doesn't have great impact strength, but that shouldn't matter for a project like this. It will not creep too badly over time. PLA can have a tendency to droop under a load when continually applied to it. ASA, not so much. It has good temperature resistance, so if you have some hot hardware in here, that shouldn't really matter. And it's also pretty UV stable, so if you have it next to a window, if the sun beating down on it shouldn't cause it to deteriorate. Okay, those important pieces of information out of the way. This thing, to print a 4U version of it, so the minimum configuration you could put together. It will take 4 top and bottom pieces, 4 cross members, 8 connectors of both the side ones and then 8 of the front ones. That will take 597 grams of material and 28 hours to print. Honestly, this ended up a little bit more materially efficient than I thought it would. And that really shines when we start to expand it. If we take it up to a 6U like I have done here, all you would need is 2 middle pieces, the mid sections, and 4 more of each of the connectors. That adds 134 grams of material and 6.25 hours of print time. So that was blank empty frame. That's all that was. So what is this configuration? How I have it here with blanking panels and handles and top and bottom, keystone, shelves, all of that. What does this take? As I have it configured here right in front of you, this took 1,511 grams of filament and 76 hours of total print time. So just over 3 days. With the $30 spool filament that I used to produce this, that's about $45 in materials to make it, plus the hardware would be another $20. So all in on the Mod10 mini rack as we built it here, we are a little less than half the price of the Desk Pi unit. But there's another point to be made about that. See, the Desk Pi at $150 doesn't have mounting hardware specifically for the stuff that I put in here. No keystone jack plates, no mounts for the Ubiquiti hardware. So if I want to outfit this Desk Pi as I have this one, I slice the parts to see how much that would take. That would take 664 grams and 36 hours of print time. Meaning that to get the Rackmate T1 to be the same as we have with the Mod10 right now would take half the print time that this took and almost half the material too. So we're really actually even further ahead of the game with the Mod10. So in the end, value is going to be in the eye of the beholder on this, whether or not it was worth it. My 3D printable modular design is a little larger. It's almost the same size as the 8U unit on the Rackmate over here, just because metal can be stronger in smaller pieces than 3D printed plastic. And at the end of the day, the Desk Pi is just going to be stronger in general. If you need a setup that's going to travel from place to place with you for some reason, that's probably a better way to go. But if you just want to have a fairly budget efficient way to produce your own mini rack, I think the Mod10 is a pretty compelling proposition. So if you want to produce your own Mod10 3D printable mini rack, where can you get the 3D print files for it? As of right now, release of this video, the STLs and a step file of the full 6U unit here, so you can modify it, remix it as you wish, are available in early release on my Patreon account, Thangs memberships, or printables. That is early release. These files will eventually be publicly available. For right now, I really need your help to support the projects that I'm producing, both this one and future projects, so please do consider picking them up from one of those platforms. I really think a lot of you folks could put together some pretty cool makes of the Mod10 mini rack, so please do tag me in them if you post them on social media. I would love to see them come together. If 3D printing this is not for you, you can find a link in the description to the DeskPi rack mate and pick one of those up as well. And I really want to stop and thank everybody who helped make this project possible. Polymaker for providing the filament, Ubiquiti for providing the networking hardware, and FlexiSpot for sponsoring this video. Please do check out the link in the description if you're interested in a high quality electric standing desk. I think that's going to wrap it up for this one, folks. I hope you found this video interesting. If you did, maybe you'll enjoy this one of renovating my main server rack with the UNAS Pro and other hardware, or this one that YouTube thinks is best for you. Get subscribed to ensure your 3D prints don't fail. It's not a guarantee, but it can't hurt. See you, folks.